In this video, we're doing another example about how to solve simple equations. And remember that solving simple equations is all about inverse operations. So when we talk about inverse operations, we mean that addition and subtraction are inverse operations, and that multiplication and division are inverse operations. And we're going to sort of undo the operations in the equations we're given. We're going to do the inverse operations in order to unpack the equations and get at the variable. We've been asked to solve for the variable, so in this first problem here, we have the equation 5x plus 4 equals 29. So our variable there is going to be x, and we need to solve for x, meaning we need to get x by itself on one side of the equal sign. So right now, x is on the left-hand side of the equation, and the left-hand side of the equation is 5x plus 4. So the first thing we want to do is get rid of this plus 4, this term that doesn't involve x. We have added 4 here in this equation, so we're going to do the inverse operation of subtraction, and we're going to subtract 4 in order to get this positive 4 out of the left-hand side of the equation. But remember, when you're solving equations, you always have to do the same thing to both sides of the equations. That's called balancing, and if you don't keep the equation balanced, you won't get the right answer. So because we're subtracting 4 from the left to do the inverse operation of adding 4, we're going to have to subtract 4 from the right as well. So we're going to subtract 4 from the right. That's going to leave us here with 5x. When we bring everything down, that 5x doesn't change. Positive 4 and negative 4, when we add those two together, we get 0. So this is going to turn into plus 0 here, and 5x plus 0 is still 5x. In other words, positive 4 and negative 4 cancel with each other, and that's what happens when we do the inverse operation with these same numbers here. So 5x plus 0 is still 5x because the identity number of addition is 0. So we just have that 5x on the left-hand side, and then on the right-hand side, we get 29 minus 4, which is going to be 25. Now remember, solving for the variable is all about getting this variable by itself on one side of the equal sign. So we have to get rid of this 5 in order to get x by itself. We have 5 multiplied by x, so what we want to do is go ahead and divide, do the inverse operation of multiplication. Multiplication and division are inverse operations. So because we have multiplication, we're going to do division. We want to do division of that same number, but remember, in order to keep our equations balanced, we also have to divide by 5 on the right-hand side. Now we have 5 divided by 5, which we know is equal to 1. So these two 5s cancel with each other, and we basically are just left with 1 times x, which is the same thing as x. Remember, 1 is the identity number for multiplication, meaning that 1, when you multiply it by something, doesn't change the identity. So these cancel, and we're just left with x on the left-hand side. Then on the right-hand side, we have 25 divided by 5, which we know is 5, so we simplify that fraction to 5, and we get x equals 5, and we've solved for our variable, because here our variable is on the left-hand side of the equal sign all by itself. So we say the value of the variable that makes this equation true is 5. And just to double check ourselves, we can plug it back into our original equation, which was 5x plus 4 equals 29. If we plug in x equals 5, instead of 5x, we get 5 times 5. We have that plus 4 equals 29. 5 times 5 is 25, so we get 25 plus 4 equals 29. And then on the left-hand side, 25 plus 4 is 29, so we get 29 equals 29, and we can see that we verified that this is true, which means that x equals 5 is a real solution to the equation we were given. Let's do one more example here. We have negative 11m plus 5 is equal to 17, and we need to solve for the variable. The variable here is going to be m, so we need to solve for m by getting m all alone by itself on one side of the equal sign. So in order to do that, the first thing we need to do is get rid of this plus 5, because on the left-hand side here, m is on the left-hand side, and on the left-hand side we have negative 11m plus 5. So the first thing we want to do is get rid of that plus 5, and because we have addition, we want to do the inverse operation, which is subtraction, and subtract that same value. But of course, we also have to do that on the right-hand side in order to keep everything balanced. Our positive 5 and our negative 5 will cancel and become 0, leaving us with just negative 11m is equal to 17 minus 5, which we know is 12. Now on the left-hand side, we have negative 11m. In other words, m is multiplied by negative 11. So what we want to do is divide by negative 11 in order to get rid of that, because division is the inverse operation of multiplication. But because we're doing it to the left, we also have to do it to the right. we're going to get our negative 11s to cancel from the numerator and denominator. Negative 11 divided by negative 11 is 1. 1 times m is just m. So we cancel those. We just get m. So we have m is equal to 12 over negative 11. If we want to, we can bring that negative sign out in front. It's a cleaner way of writing our final answer. Instead of associating negative with the numerator or denominator specifically, just bringing it out in front and saying negative and then the fraction 12 over 11 for our final answer. Now, we've solved for the variable, but if we want to double check ourselves, we can. So plugging this value for m back into the original equation, instead of negative 11 times m, we'll get negative 11 times the value we found, so negative 12 over 11, and then plus 5 equals 17. And let's see if we get this same kind of situation here of 29 equals 29 if our left and right hand sides are equal to one another. So the first thing we see here is that we have a negative times a negative. Those are going to cancel with each other and become positive. Here we have an 11 in the numerator and an 11 in the denominator, so those two will cancel with each other, and we'll just be left with 12 plus 5 equals 17, which we know is 17 equals 17, and we can see that the left-hand sides are equal to one another, which means that m equals negative 12 elevenths is in fact a solution to the equation that we were given.